This is an audiovisual presentation on probability. Probability is the study of events which may or may not occur. Suppose E is an event and H is the number of ways event E can occur, and N is the total number of possible outcomes. Probability of the event E will be equal to the number of ways event E can occur divided by the total number of possible outcomes. So probability of the event E will be equal to H over N, where H is the number of ways event E can occur and N is the total number of possible outcomes. Now let's proceed. Let's consider a class. The number of boys is 12 and the number of girls in the class is 18. So if you want the total number of students in the class, it will be 12 plus 18. That's the number of boys plus the number of girls, and this is equal to 30. That is 12 plus 18 equals 30. Now probability of B, that is probability of boys in the class, will be equal to the number of the boys divided by the total number of students in the class. The number of the boys is equal to 12 divided by the total number equals 30. That means that probability of the boys in the class will be equal to 12 over 30. And 6 goes into 12 2 times, and 6 goes into 30 5 times. So probability of boys will be equal to 2 over 5. Now probability of girls will be equal to the number of girls divided by the total number, and the number of girls in the class is 18 divided by the total, that is 30. 6 goes into 18 3 times, and 6 goes into 30 5 times. So probability of girls in the class is equal to 3 divided by 5. Now let's look at some terms. An experiment is any operation whose outcome cannot be predicted with certainty. An example is tossing of a dice. We have all seen a dice before. When you toss a die, you never can tell whether 1 is to show up, 2 is to show up, 3 is to show up, 4, 5, or 6, because a dice has 6 faces. So when we talk of an experiment is any operation whose outcome cannot be predicted with certainty. So when we toss a die, unless it drops on the surface, you never can tell what is going to show up. And so tossing a dice is an experiment. Now a trial. A trial of an experiment is a single performance of the experiment. Example, tossing a dice once is what you call a trial. A trial of an experiment is a single performance of the experiment. So when you toss a dice once, because it's a single performance, we call it a trial. Now random sampling. This is choosing a sample from a population without being biased. So when we say random sampling, it means that you are choosing a sample from a population without being biased. A sample space. The set of all the possible outcomes of a trial of the experiment is what you call the sample space. That is the set of all the possible outcomes of a trial of the experiment. Example, when a dice is tossed once, the sample space is 1, 2, 3, 4, 5, 6. So the sample space is the set of all the possible outcomes. So 1 is a possible outcome because 1 can show up. 2 is a possible outcome because 2 can also show up. 3 is a possible outcome. 4 is a possible outcome. 5 is a possible outcome. And 6 is a possible outcome. So the set of all the possible outcomes is what we call the sample space. Now, example, when a coin is tossed once, a coin has two sides. One side is called the head, and the other side we call it the tail. So when a coin is tossed once, the sample space is either the head will show up or the tail will show up. So we have HT. That is the sample space. Now let's look at the laws of probability. Law 1. Probability of an event is greater or equal to 0, but less than or equal to 1. So that's the range of probability from 0 to 1 inclusive. Now 2. Probability of a sample space is equal to 1. 3. Probability of an event plus probability of no such event is equal to 1. Now the E bar means no such event of E. So probability of an event E plus probability of no such event is equal to 1. Law 4. Probability of an empty set is equal to 0. Now we proceed. When a dice is tossed once, the sample space is 1, 2, 3, 4, 5, 6. So probability of the sample space will be equal to probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. Now probability of 1 is 1 out of 6. Probability of 2 is also 1 out of 6. Probability of 3 is 1 out of the 6. Probability of 4 is 1 out of the 6. Probability of 5 is 1 out of the 6. And probability of 6 is 1 out of the 6. So the total, that is probability of the sample space, will be equal to 1 over 6 plus 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 1 over 6, and this is equal to 1. So probability of the sample space is equal to 1. So that's the explanation of the law that says that probability of a sample space is equal to 1. Now, when the same dice is tossed once, the sample space is S equals 1, 2, 3, 4, 5, 6. The number of items of the sample space is the number of S, that is 6. So we have 1, 2, 3, 4, 5, 6. So number of X equals 6. Now let E be the event of even numbers. Now among 1 to 6, the even numbers are 2, 4, 6. So when we say E is a set of even numbers out of the sample space of a coin, of a dice being tossed once, the even numbers is 2, 4, 6. That is E. So when we say E bar, that is the set of not even numbers, and that will be 1, 3, 5. That will be 1, 3, 5 from the sample space. So probability of the even numbers will be equal to number of even numbers divided by the number of the sample space. And the number of even numbers is 1, 2, 3. So we have 3 divided by the number of sample space is 6. So probability of even numbers is 3 over 6. And this is equal to 1 over 2. Now E bar equals 1, 3, 5. So probability of E bar, not even numbers, will be equal to number of not even numbers divided by the number of sample space. And the number of not even numbers is 1 3, 5. So we have 1, 2, 3. That is 3 over the sample space is 6. And 3 over 6 is equal to 1 over 2. So probability of even numbers plus probability of no even numbers will be equal to half plus half, and this is equal to 1. And that is the explanation to the law that says that probability of an event plus probability of no such event is equal to 1. That is the understanding. Now let's look at compound events. Compound events are events that are joined by or and end. Take note that the or corresponds to union. So when we say A union B, it denotes A or B. And corresponds to intersection. So A intersection B denotes A and B. Now for compound events, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A union B equals probability of A plus probability of B minus probability of A intersection B. Now example, given that probability of X equals 0.35, probability of Y equals 0.45, probability of X intersection Y equals 0.2. Find probability of X union Y. Find probability of X union Y. So from compound event, probability of X union Y is equal to probability of X plus probability of Y minus probability of X intersection Y. So probability of X union Y equals 0.35, that is probability of X is given in the question, plus 0.45, that is probability of Y is also given, minus probability of X intersection Y is given to be 0.2. So probability of X union Y will be equal to 0.35 plus 0.45 minus 0.2, and this is equal to 0.6. So the probability of X union Y is equal to 0.6. Now we have mutually exclusive events. Mutually exclusive events. For mutually exclusive events, A intersection B is empty. That is, the event A has nothing in common with the event B. That is why A intersection B is empty. So if A intersection B is empty set, then probability of A intersection B will be equal to 0, because probability of empty set is equal to 0 from the law. So if A intersection B equals empty set, then probability of A intersection B will be equal to 0. And therefore, from the compound event, probability of A or B, which is equal to probability of A union B, will be equal to probability of A plus probability of B. Now, independent events. For independent events, the occurrence of one does not affect the occurrence of the other. So probability of X intersection Y is equal to probability of X times probability of Y. That is for independent events. Example, X and Y are two independent events such that probability of X equals 3 over 7 and probability of X intersection Y equals 2 over 5. Find I, probability of Y, II, probability of X union Y. Take note that we are told that X and Y are two independent events. Now solution, probability of X equals 3 over 7 and probability of X intersection Y from the question is 2 over 5. And we are asked to find probability of Y. Now for independent events, probability of X intersection Y is equal to probability of X times probability of Y. Probability of X intersection Y equals 2 over 5. So by substitution, we have 2 over 5. And this is equal to probability of x is equal to 3 over 7 times probability of y is what we are calculating for. So now if we have 2 over 5 equals 3 over 7 times probability of y. Now 3 over 7 times probability of y will be equal to 3 probability of y divided by 7. So 2 over 5 is equal to 3 probability of y divided by 7. Now we cross multiply. So 5, the denominator on the left hand side multiplies the numerator on the right hand side. So we have 5 times 3 probability of y is equal to 7 times 2 is 14. Now 5 times 3 equals 15. So we have 15 probability of y is equal to 14. We are solving for probability of y, so we divide both sides by 15. When we divide the left hand side by 15, we are left with probability of y. And when we divide the right hand side by 15, we have 14 over 15. So probability of y is equal to 14 over 15. Now probability of x intersection x union y. Probability of x union y is equal to probability of x plus probability of y minus probability of x intersection y. So probability of x union y is equal to 3 over 7, that is probability of x, plus 14 over 15, that is probability of y, minus 2 over 5, that is probability of x intersection y. Now, if you have 3 over 7 plus 14 over 15 minus 2 over 5, this is what we are simplifying. This is addition and subtraction. So what we have to do is to find the LCM of 7, 15, and 5. Now 7 goes into 105 15 times. Then we multiply the 15 by the numerator. So 15 times 3, the answer is 45, plus 15 also goes into 105. Then whatever we get, we multiply by 14, and that will give us 98. Take your time and simplify this. Minus 5 also goes into 105. This is 21 times. When we multiply the 21 by 2, the result is 42. So we have 45 plus 98 minus 42. And 45 plus 98 is equal to 143 minus 42, all divided by 105. So 143 minus 42 is equal to 101 divided by the LCM, that is 105. This means that probability of x union y is equal to 101 over 105. Now let's look at the toss of a coin. The toss of a coin. And this is the general formula or the general expression that we use in finding the number of elements of the sample space. Now, n equals 1 means a coin is tossed once. So when the coin is tossed once, the sample space will be HT. That's the head and the tail. So we have 1, 2. Now when n equals 1, then 2 raised to the power n will be 2 raised to the power 1. And that is 2. That is how come the number of elements is also 2. So we have 1, 2. When n equals 2, it means the coin is tossed twice. And the sample space will be HH, HT, TH, and TT. So we have 1, 2, 3, 4. Now when n equals 2, then 2 raised to the power n will be 2 square. And 2 square will give us 4. That is why we have 1, 2, 3, 4. But now let me show you how you can generate the sample space for the toss of coin for a number of times. Now, when a coin is tossed once, the sample space is HT, so we have HT. When another coin is also tossed, when we toss the coin once again, we have HT. Take note, that tossing a coin twice is the same as tossing two coins once. I repeat, when you have a coin and you toss the coin twice, it's the same as when you have two coins and you are tossing it once. So when a coin is tossed once, you have a head tail. When a coin is tossed once, you also have a head tail. Now, if you are finding the sample space for a coin being tossed twice, it means that you have to match the HT against HT. So we have H by H, and that's HH. H by T, and that is HT. T by H, that is TH. And T by T, that is TT. So when the coin is tossed twice, that is when n equals 2, the sample space will be HH, HT, TH, and TT. That is how come we have HH, HT, TH, and TT. So we have head, 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 tail, tail, head, and tail, tail. Now, n equals 3 means that the coin is tossed 3 times. And when n is 3, 2 raised to the power 3 will give us 8. So the number of sample space is 8. Now, when a coin is tossed 3 times, it means that we match 1 against 2 because HH, HT, TH, and TT is the sample space. Is the sample space for when a coin is tossed twice, and HT is the sample space when a coin is tossed once. So if you want to find the sample space when a coin is tossed 3 times, then you have to match HT against HH, HT, TH, and TT. Now, H by HH will give us HHH. H by HT will be HHT. H by TH will be HTH. H by TT will be HTT. T by HH will be THH. T by HT will be THT. T by TH will be TTH. And T by TT will be TTT. So when we count, we have 1, 2, 3, 4, 5, 6, 7, 8. So the number of sample space will be equal to 8. Now we have the throw of a dice, and the expression for determining the number of sample space is 6 raised to the power n. Now when n equals 1, it means that the dice is thrown once. So the sample space will be 6 raised to the power n, where n equals 1. So we have 6 raised to the power 1, and that is 6. That is how come we have s equals 1, 2, 3, 4, 5, 6. So the number of sample space will be 6. Now, when you have a dice being thrown twice or 2 dice being thrown once, it means you have to match 1, 2, 3, 4, 5, 6. That's the sample space when the dice is tossed once against another die being tossed once. Now we match 1 to 6 against 1 to 6. So we have 1 by 1 is 1, 1. 1 by 2, 1, 2. 1 by 3, 1, 3. 1 by 4, 1, 4. 1 by 5, 1, 5. 1 by 6, 1, 6. 2 by 1, 2, 1. 2 by 2, 2, 2. Now I advise you to fill in the empty spaces. Here we have 3 by 5, so we have 3, 5. Here we have 4 by 3, we have 4, 3. Here we have 6 by 2, we have 6, 2. And here we have 6 by 6, and that is 6, 6. I advise you to fill the other spaces provided. And this will be the sample space when the dice is tossed twice. This will be the sample space when the dice is tossed twice. Now we have drawing with replacement. Drawing with replacement. Now this one means that when you say drawing with replacement, what you mean is assuming you have a set of balls of different colors in a box as shown. When we are drawing, it means we are taking a ball out. With replacement means that assuming we are taking 2 balls, from this box. When we take the first ball, before we take the second, we put back the first before the second is taken. That's the meaning of drawing with replacement. Assuming we are taking 3 balls from here, when the first one is drawn, we put it back before the second is taken, and we put the second also back before the third is taken. That's what you mean by drawing with replacement. So when you consider this box, we have number of red balls is 5. That is 1, 2, 3, 4, 5. Number of black balls is 4. Number of green balls is 3. So if you want to find the total, is 5 plus 4, that is 9. 9 plus 3 is 12. So the total number of balls in the box is 12. Now, probability of picking a red ball will be equal to the number of red balls divided by the total number of balls. So probability of R1 means that the first ball to be taken from the box is red. And because the number of red balls are 5, the probability of R1 will be equal to 5 over 12. Now probability of R2, that is, we are taking the second ball from the box. But before we take this second ball, remember that we put it back. The first one we took back before we take the second one. So at the end of the day, before we take the second one, the total number of red balls is still 5. Divided by the total in the box, that is 12. Now, the number of the number of black balls is number of black balls divided by the total. So probability of B1 means that we are taking a black ball from the box. And because we have 4 black balls, the probability of B1, the first one you are taking, is coming from the 4. So we have 4 over 12. Probability of B2, before we take the second one, the first one must be put into the box before we take the second one. And so probability of B2 will be equal to 4 over 12. It's still the same. Now probability of green will be number of green balls divided by the total number. So probability of G1 means the first ball we are taking from the box is green, and we have 3 green balls. So probability of G1 will be equal to 3 over 12. Probability of G2 will be equal to the same 3 over 12 because we put the first one back before the second one is taken. Now let's look at drawing without replacement. With this one, when we take a ball, we don't put it back and we take the second one. Now the number of red balls is 5. The number of black balls is 4. The number of green balls is 3. And the total is 12. Probability of red balls will be number of red balls over the total number of balls. So probability of R1 is equal to 5 over 12. Probability of R1, the R1 means the first ball we are taking is red. And because the number of red balls is 5, the answer is 5 over 12. Now, there is something I want you to look at here. Probability of R is number of R over number of T, where R is the number of red balls, number of T is the total number. Now, probability of R1 is equal to 5 over 12. That is, the red balls were 5 in the box. So probability of R1 will be equal to, it means we are taking that one from the 5, so it is 5 over 12. Now, probability of R2 means that we are taking another red ball from the box. And by the time we get to R2, that is, by the time we are taking the second ball, that is red, the total number of red balls would have been 4. So we are taking the 1 out of the 4. Divide by, take note that the total will now be 11. The total will now be 11 because 1 has already been taken. Now, probability of B, that is black ball, will be equal to number of black balls over the total number. So probability of D1 means that the first ball taken out is black. and the number of black balls is 4. So the answer is 4 over 12. Now, if probability of B1 give us 4 over 12, probability of B2 means that the second ball that we are taking is also black. But take note, by the time you are taking the second black ball, the first one has not been put back. So the total number of balls in the box will now decrease to 11. Instead of 12, will decrease to 11. And the total number of black balls instead of 4 will now decrease to 3 because one has already been taken and it wasn't put back into the box. So probability of B2 will be equal to 3 over 11. Now, probability of green ball will be number of green over the number of total. The number of green balls is 3. So probability of G1, that is the first ball to be taken, is 3 over 12. So if probability of G1 is equal to 3 over 12, then probability of G2 means that you are now taking the second green ball from the 2 left. So it will be 2 over 11. Why is it 11 but not 12? Because the first green that was taken out was not put back. So that has decreased the total number of balls in the box. Now let's look at this example. Probability of R1 intersection R2. This means that we are taking 2 red balls, one after the other, is without replacement. So the first one, R1, will be equal to 5 over 12 because we have 5 red balls. So 1, 2, 3, 4, 5. And the total in the box is also 12. So it's 5 over 12 times. By the time you are taking the second one, you are left with 4 red balls. So you take 4, we take it from the 4, so it will be 4 divided by 11. Because 1 is already out, the total has now decreased from 12 to 11. Now 5 times 4 is 20. 12 times 11 is 132. So probability of R1 intersection R2 is equal to 20 divided by 132. Now let's consider this example. Probability of R1 intersection B2. This means that the first ball to be taken is red. And the number of red balls is 5. So it means you have 5 over 12. Now, when the first red ball has been taken out, take note that we have B2. That means that the second ball we are taking is coming from the black. And the number of black balls is 4. So it's 4 over 11. Why is it 11 but not 12? Because the first one, the red ball that was taken out, was not put back. And so this is equal to 5 times 4 is 20, and 12 times 11 is 132. So probability of R1 intersection B2 is equal to 20 divided by 132. Now let's consider this example without replacement. Probability of R1, R2, B3. Now this means that the first ball taken out is red. The second ball taken out is red. And the third ball taken out is black. And take note, this without replacement. So when we take the first one, we don't put it back before the second one is taken. So probability of R1, the total number of red balls is 5. So it will be 5 over the total, that is 12. Times R2. That's the second ball we are taking is also red. And because one has already been taken, we are left with 4. So it will be 4 over the total, that is 11. Because the first red ball taken was not put back before the second one was taken. Now times B3, that is the third ball to be taken is coming from black. And the number of black balls is 4. So we are taking it from the 4. So it's 4 divided by 10. It's 4 divided by 10. It's 4 divided by 10. And this is equal to 5 times 4 is 20. And 20 times 4 is 80. Divided by 12 times 11 times 10 is equal to 1,320. Is equal to 1,320. This is the end of our presentation.